this video will look at beginning to introduce some programming theory. In particular, it'll be looking at variables, constants and data types. And as I said, it'll be covering programming from a more theoretical point of view, but there may be some practical examples in pseudocode or Python, just to give a sort of context. So programs, they produce outputs. Now it might be something on the screen being displayed, or it might be a sound from a speaker. And if we were to actually try and get our program to produce some text on the screen, to output some text onto the screen, in Python we'd use the print function. So print bracket speech marks hello world would actually display hello world on the screen. Now our programs will also require inputs. Programs will ask the user perhaps to enter data into the computer, and that is regarded as an input. So for example, if the program wanted to request someone's age and their address, perhaps on an online form, anything that is then typed in would be considered an input. Or if a program, a game for example, was requesting some directional data from a gamepad, then those the movements on the gamepad would be your inputs for the program, and it might allow a character on the screen to be controlled. So once data has been entered, the computer has to be able to store that data, and it does so using something known as variables. Now a variable, okay, is a memory location, okay, a single memory location. It can store a piece of data of a particular data type, and you can visualize it as a box, if you like, that's been given an identifier, so a name. For example, in this case it's been given answer, and it can store some data. And it's important to recognize that a variable can have its data changed, overwritten, whilst the program is running. Now there are some conventions when we program variables in terms of how we actually write the names of them. Sometimes we will write them in a convention where the first letter is lowercase, and then any other words as part of the name of the variable are then started with uppercase, so that's called camel case. And also we can't start the name of a variable with a number. It has to be an alphabetical character. And underscores are good as well if you want to split up the perhaps several words that are used to form the name of a variable. Now variable assignment is the process by which you put data into a variable. So in most languages, the operator, the symbol that they use is an equal sign. And the following things are really important. The assignment operator mustn't be confused with the operator to check if a value is mathematically equal to another. So for example, in Python they use a single equal sign for assignment and a double equal sign to see if something is mathematically equal to something else. Assignment is always written from right to left as well, so the variable is placed to the left of the equal sign and the value that you want to put into that variable is put to the right, like so. And you can read that as x becomes 7. So here's an example of an input statement in Python and the value that would be typed in being stored in a variable. So you can see here that the input statement is assigned to the variable. Whatever's typed in as a result is going to be put into that variable. So here the program is asking for someone to type in their name, and whatever they type in is going to be assigned into the variable called name. And then if we were to print out name afterwards, you can see that that is exactly what happens. It displays on the screen. That output is sent to the screen for displaying. Now constants are also memory locations. They're very similar to variables in that respect. However, the difference here is that a constant cannot change its value or the data that it's holding whilst the program is running. It cannot be overwritten. So why might we want to use some constants in our program? Well, imagine that we have a value that can't change, that just won't change. For example, we might be making a mathematics program where we want the value of pi. well, pi will never change, so we want that to be set in stone. We don't want to have a situation where we are coding and we accidentally overwrite the value that's stored in pi. So making it a constant means that it can't be overwritten. Or it might be that you have VAT, you might be doing an accountant's program, and VAT is set in stone for a good duration until the government change it, so you might want to set that as a constant as well. And another good thing is that once you've declared that a variable is a constant and might hold a value, you could actually just, if for example the law changed and VAT changed, you could actually redeclare it as a reassign it with a new number, so that one change affects the entire program globally. So it's often very good to have constants where you have a value that you don't really want to change whilst the program is running. Now, when a variable is created in a program, the computer needs to know what sort of data type the variable is going to hold. And it needs to know that for two reasons. Because how an item of data is stored in a computer will depend on its data type. So the computer will allocate some memory of the correct size of the variable declared, and it can't do this without knowing what type of data the variable is going to hold. So for example, a string data type needs a lot more memory than an integer. So it's important that when a variable is declared, it knows what sort of data type it's going to hold, so that the memory can be prepared for that variable. Also, how an item of data is manipulated in the computer depends on its data type. So if you were to consider the integer 2 and the string 2, both of those bits of data will be stored in the computer in binary slightly differently. Their binary values will differ. With the integer, the computer would be able to perform arithmetic on the binary value. However, with the string, it wouldn't be able to perform arithmetic on that binary value. So it's really important that a computer knows what sort of data a variable is going to have, so that the program can manipulate the data within those variables accordingly. Now, in terms of the different types of data that you need to be aware of, you need to know that there are integers, which are whole numbers. They typically need 2 to 4 bytes of memory. Real, which is also known as float in Python. So a real number is a decimal number, and that will need slightly more memory. A string is a collection of alphanumeric characters, maybe some white space, maybe punctuation. So basically any characters on a keyboard. And every character used will require 1 byte. So, you know, if you have a string which contains quite a lot of words, then obviously a lot of memory will be required for that particular variable. A Boolean data type is either true or false. It requires just 1 bit of data. It'll either be a 1 if it's true or a 0 if it's false. So Boolean data types need a very small amount of memory. And characters, as we've said with strings, each character requires 1 byte. If it's a character data type, then that variable will only hold 1 single character, and therefore will only require 1 byte in size of 1 byte of memory in order to store that particular data.